Mars has always been the dream, the next step, the backup plan, the planet humanity is racing to reach before it's too late for this one. But here's the question nobody asks. Instead of sending humans to Mars, what if we sent the entire Earth? What if our planet, oceans, atmosphere, forests, cities sat exactly where Mars sits today? Would we finally have our second home? Or would Earth become the second Mars? Before we continue, your question for today: if Earth replaced Mars, do you think Mars was once like Earth, with oceans and life? Drop your answer in the comments. New here? Subscribe. This is where we move planets with real science. Mars sits at 228 million kilometers from the Sun. Earth sits at 150 million. We're moving significantly further out. And distance from the Sun isn't linear when it comes to warmth. At Mars's distance, Earth receives only 43% of the solar energy it gets today. Not half, not slightly less, 43%. Less than half the sunlight, less than half the warmth. But here's what makes this fascinating. Earth isn't Mars. Earth has something Mars lost billions of years ago: a thick atmosphere, vast oceans, a powerful magnetic field, a living dynamic system that regulates its own temperature. So the question isn't whether Earth gets colder at Mars's orbit. It does, dramatically. The question is, how long does Earth fight back? The moment Earth settles into Mars's orbit, the cooling starts. Not catastrophically, not instantly, but relentlessly. Average global temperatures drop by roughly 30 degrees Celsius within decades. The tropics, currently averaging 25 to 30 degrees, cool to near freezing. Temperate regions, Europe, North America, China, plunge below zero permanently. The polar regions become uninhabitable wastelands of extreme cold. But here's what's remarkable. Earth's atmosphere, thick, dynamic, full of greenhouse gases, fights back. The greenhouse effect that we currently consider a crisis becomes a lifeline. Every molecule of CO2, every drop of water vapor, desperately needed to trap the small amount of solar energy still reaching the surface. A warmer core, active volcanoes still pumping heat and gases. Earth at Mars's orbit isn't dead, not yet. It's struggling, and for a few thousand years, it might even be livable. In the right places. The equatorial band, that narrow strip of Earth running along the equator, receives the most direct sunlight even at Mars's distance. Temperatures there might stabilize between -10 and +15 degrees Celsius. Cold, harsh, unforgiving, but survivable. Iceland today averages -10 in winter, and humans have lived there for over 1,000 years. Antarctica has research stations operating year-round at -30. Humans are extraordinarily adaptable. In a world where Earth sits at Mars's orbit, civilization doesn't spread across continents, it contracts. Every human being on Earth migrates toward the equator. The great cities of the northern and southern hemispheres, London, New York, Tokyo, Sydney, abandoned within generations. Not to war, not to disaster, simply to cold. A slow, inexorable migration of 8 billion people toward a narrowing band of survivable temperature. The entire human race compressed into a strip of land circling the planet's middle. But Earth's atmosphere can only fight for so long. As temperatures drop, the oceans cool. As oceans cool, they absorb more CO2 from the atmosphere. Less CO2 means less greenhouse warming. Less warming means lower temperatures. Lower temperatures mean more ice. More ice means more sunlight reflected back into space instead of absorbed as heat. The feedback loop runs, but this time in reverse. Not toward Venus's hellish heat, toward Mars's lethal cold. The ice advances from the poles. Within tens of thousands of years, the ice sheets reach the equatorial band, the last refuge of human civilization, compressed further and further. until the equatorial strip that once housed 8 billion people can no longer support the weight of that number. Not because of war, not because of politics, because the sun, from 228 million kilometers away, simply cannot deliver enough warmth to keep a planet this alive. Here's the extraordinary part. Mars wasn't always the frozen desert it is today. 4 billion years ago, Mars had a thick atmosphere, liquid oceans, river valleys, a magnetic field, possibly life. We know this because we can see the evidence: ancient riverbeds carved into Martian rock, mineral deposits that only form in liquid water, a northern hemisphere that may have been an ocean floor. Mars didn't start as a dead world. It became one. When its small core cooled, its magnetic field collapsed, solar wind stripped the atmosphere, the oceans froze and evaporated, and what was once, possibly, a living world became the rust-colored desert we see today. Earth at Mars's orbit follows the same path, slower because Earth is bigger, more geologically active, but the same path. The only question is, how far along that path does humanity survive? We spend billions trying to reach Mars, to terraform it, to make it livable, to turn a dead world into something Earth-like. But Earth at Mars's orbit shows us the problem in reverse. Even Earth, the most perfectly configured living planet we know, cannot survive indefinitely at Mars's distance. The warmth fades, the ice advances, the atmosphere thins. Given enough time, Earth becomes Mars. So when Elon Musk talks about making humanity multiplanetary, about backing up our civilization on Mars, the science of this thought experiment suggests something important. Don't wait too long, because the backup plan has an expiration date, and so does the original. The universe doesn't wait.